color. Our day-to-day world is filled with it. This cup, that guitar, my shirt, my hair, me. Our world does not look like a black and white movie. But what is color? As Isaac Newton stated, color is not a quality of an object. It is not something created by the things around you. Well, then what is it? Color is the way your brain perceives light bouncing off of objects. When the light in this room hits the cup absorbs some of the light and reflects the rest. This cup appears green because of the wavelengths it's reflecting. Red objects reflect red light, blue objects reflect blue. When an object reflects all wavelengths equally, it appears white, and when it absorbs the majority of light, it appears black. Those specific wavelengths enter the eye and are refracted onto the retina, where special cells called photoreceptors absorb the light and send signals to the brain through the optic nerve. And the brain tells you that the cup is green, the guitar is brown, and that part of my hair is blue. The eye contains two different types of photoreceptors, called rods and cones.
Jerry, my rods and cones are all screwed up.
These cells contain substances called photopigments. Rods contain a photopigment called rhodopsin, which is most sensitive to bluish light. Humans, on average, contain 120 million rods, and the majority of them are located at the edge of the retina near your peripheral vision. Rods create an image that looks something like this: black and white with blurry edges and a low level of detail. Rods are used most at low levels of light, which is why at night colors appear dimmer and why neon objects seem to glow at dusk. Humans have many fewer cones than rods, only around 6 to 7 million. They are what cause us to see color. Cones consist of 3 cell types, each tuned to a distinct wavelength response maximum, centered at either 430, 535, or 590 nanometers. Blue, green, and red. These different types contain photopigments that are sensitive to those different wavelengths. The brain takes the signals and their strength to determine what color an object is. Cones are more sensitive than rods and create a clearer image, but also require more light to function, which is why rods are used more at lower levels of light. Cones are most concentrated at the center of your vision, called the central fovea. Not everyone sees color the same. Some people can't distinguish between red and green, others confuse blue and yellow, and others can't distinguish color at all. It's even possible for some brains to have labeled their cones differently than most of us and see colors backwards, like seeing blue as yellow and vice versa. Color is one of the most interesting aspects of our world, and understanding it is important to developments such as color TV and computer screens. It's part of survival instinct. A world without color seems bland and boring. Color can even be overwhelming at times, but it's a big part of what makes this world beautiful. I'm glad to know color, and that my rods and cones work the way they meant to. Aren't you?